Welcome to Spring LIB.
Now in this question, we have a wave function that's given by this formula here, and we need to find some of its parameters, some of the wave parameters. To start, let's write the general form of the wave function. Y of x and t is equal to the amplitude multiplied by cosine kx plus or minus omega t. And as we can see here, this is the amplitude, this is the wave number, and this is the angular frequency here. And the positive sign here, the positive sign, it implies that the motion of the wave is to the negative x direction. That's what does the positive sign means. Now, in part A, we need to find the period t, and we need to find the wavelength lambda. So the time it takes to pass a specific point and the wave or the horizontal distance. So let's start with t. We will write t equal 2 pi over omega, which is equal to 2 pi divided by 4.5 or 5.4 second inverse, and that's equal to 1.16 seconds. Lambda is the horizontal distance is 2 pi divided by the wave number k, which is equal to 2 pi divided by 0.45 centimeter inverse, which is equal to 13.96 centimeters. Now notice here you should keep the units as you start with them. You can, of course, convert the units to meters. You can convert the distance to meter, but I choose here to keep it in centimeters. In part B, we need to find the wave number and how many waves will pass through a specific point in seconds. So the wave number is given from the formula or the wave function. It's just we need to say k is equal to 0.45 rad per centimeters, and the frequency is just 1 over the period, which is equal 1 over 1.16 seconds, and that's equal to 0.862 hertz. So this is the frequency and this is the wave number. The last part C is asking us to find the speed of the wave at that point and the maximum speed of this wave. To find the speed, we'll write to find the speed at that point, we'll write v is equal to frequency multiplied by lambda, as we done before. So that is 0.862 hertz multiplied by about 14 centimeters. Oh, let me write this down. Let me write this down here. Okay, so it's equal to 0.862 hertz multiplied by 13.96 centimeters. And this is equal to 12 centimeters per second. So this is the velocity at that point, or the speed of the wave at that point. And the maximum velocity, so the maximum velocity Vmax is equal to the first time derivative, so partial y over partial t, and I'm going to write here max. Now let's start first by finding the time derivative of the wave function. So partial y over partial t is equal to 3.75 centimeters, which is the amplitude, multiplied by the wave number, which is 5.4 second inverse, multiplied by sine, and because it's the derivative of cosine, we'll add a negative sign here, so negative sine 0.45 centimeter inverse times x plus 5.4 second inverse times t. And to make it maximum, the sine must be equal to 1, because the maximum value of the sine function is 1. So this is the condition here. Therefore, Vmax is equal to 3.75 centimeters multiplied by 5.4 second inverse. And that's equal to 20.25 centimeter per second. So this is the maximum speed of the wave.